Hello there. I'd like to welcome you to the Chapter 10 review session for Docere, also called the Chapter 10 Study Guide. And I've drawn a beautiful picture for you with a stick figure fishing in the lake. So here we go. These are 20 questions. Of course, it's not really 20 questions because I can't count. Question number 1. Have the same picture from the first slide. And when it rains, what happens to that rain? What are some things that can happen to the rain? Where does it go? So I don't really draw the answer, but it can run off into the lake, or it can infiltrate or percolate into the ground and thus join the groundwater. So I've labeled the part of the groundwater here as label A. So that's the part of the groundwater system that's beneath the surface that is not full of water. So what is that called? That's the unsaturated zone, and of course B is the saturated zone, and separating A and B is the water table. So question number 2, I have a picture from a previous chapter. This is a very beautiful picture of a pink granite. Now we're going to consider this igneous rock in terms of its capabilities of dealing with water. So what would you say about its porosity? Would it have a high porosity or a low porosity? Okay, it has a low porosity because this is a crystalline igneous rock, so it's not really going to have the ability to hold water. And what about permeability characteristics? Can it allow water to transmit through it? And the answer is no, of course not. So now we're going to get into a little bit finer detail with porosity and permeability, and we're going to talk about high porosity first. What does it mean to have high porosity? Well, that means that you have sediment that's kind of loosely stacked, but there are pore spaces, and in those pore spaces, water can be stored. What does it mean to have a low porosity? This means that you have a very fine-grained sediment, such as a silt or clay, and the silt and clay can't really hold a lot of water. So porosity and permeability are very intimately linked. So now let's get into high permeability. What does that mean? Well, it means that water, back with the high porosity sediment, that means that water can transmit through this material pretty good because it has a high permeability. If a sediment has a low permeability, that means that the water can't transmit through it because probably it has a low porosity. So the water is going to have a tendency to make a big pool at the top. So now let's differentiate between the word aquifer and aquiclude. Do you know the other word for aquiclude that also starts with an A? That is aquitard. So talk to me about an aquifer in terms of its porosity and permeability characteristics. Will it have a high or low porosity? Will it have a high or low permeability? Well, if it's an aquifer, it'll hold water and allow water to transmit through it. So it'll have both a high porosity and a high permeability. Now, what about an aquiclude as far as its porosity and permeability? Well, believe it or not, it could actually have a high porosity. It could hold water. But the key to being an aquiclude or an aquitard is that it will have a low permeability. It will not allow water to flow through it. So now to put you to the ultimate test, we have a picture from a previous chapter. This is from chapter 6. So does this picture show you primary or secondary porosity? Primary or secondary porosity? And the answer is it's going to have a primary porosity because this is probably what happened when the sediment was deposited. And we're assuming in this picture that the sediment is not glued together by natural cements. It's just loose sand like on the beach. So what about its permeability characteristics? Would it have a high or low permeability? And it would have a high permeability because the water can easily transmit through those pores. So now we have a conglomerate, which is a sedimentary rock. Now talk to me about primary or secondary porosity in this rock. Can this rock hold a lot of water? The answer is no, because it's a very hard rock. Okay, it's almost like a granite. What about its permeability characteristics, high or low? Again, that's going to be low because this is a pretty lithified rock, so it's not going to be able to soak up water through it. So now we have a partial picture from Chapter 10, and I need you to be able to ask or answer, is this actually a picture of an aquifer? And the answer is yes. So if it's an aquifer which is storing water and holding water, what type of aquifer is shown? This is an unconfined aquifer, and this is called the what zone that starts with a UN. This is unsaturated. Down here we have obviously the saturated zone, and the interface between the unsaturated and saturated zones are called the water table. So question number 6, I'm going to take you now to somewhere kind of yucky. This is a big hole in the ground that's holding a lot of trash, and that trash is stinky because it's releasing, among other things, a lot of methane. So this is a landfill, is what most people would call this, a big hole full of trash. And this has a clay liner on the bottom of this landfill. But the question is, why is clay used? Why clay? Why not put just gravel or a high porosity or permeability material there? And that is in itself the answer, because you want a low permeability or an impermeable barrier to not allow water and nasty gross stuff from the landfill to seep into the groundwater. And by the way, that nasty stuff is called leachate. Okay, question number 7 is another picture from a previous chapter. Okay, can you circle or indicate somehow the recharge area for this picture? Oops, I don't know if you recognize this, but this is a granite. Is granite going to be a good aquifer? Is that going to be holding a lot of water and allowing water to transmit through it? Well, the answer is no, so it's not really going to have a recharge area because it's not even an aquifer. So now we have a soil profile from Chapter 5, and this is soil at the top and, of course, bedrock down below. So talk to me about its permeability characteristics. Is a soil permeable? Yes. Is it porous? Can it hold water? Yes. Okay, and that's the answer to that question. It can hold water, so I guess you might consider it part of the groundwater system in some places. Okay, the key to this picture is what I've circled here, fractures. So would this be an example of primary or secondary porosity? Primary or secondary porosity? And this one is secondary because primary porosity only is formed when the rock is deposited. So if you have fractures in your rock, that indicates that it could be a crystalline, igneous, or metamorphic rock. Question number 8. I'm drawing some nice good stuff for you. This is sandstone, which underlies the earth. And this is a blue level that separates the unsaturated from saturated zone, called the water table. Okay, so the question now in question number 8 is, where is the recharge area for this picture? And the answer is the recharge is really everywhere, because when it rains, the water will percolate or infiltrate into this unsaturated aquifer, or unconfined aquifer, sorry. Okay, same picture. I guess this is a continuation of question 8 with the water table. Okay, and I erase the arrow there. Okay, is there a discharge area shown in this picture? Is there discharge shown? And the answer is no. One way that water could potentially discharge from an aquifer, how would that manifest itself when water comes out of the ground? Well, that would be in the form of a spring. So I do not see any springs in this picture. So now what I'm doing is that I'm doing the same type of groundwater setup, but this time I've added a tube that's placed into the saturated zone. So that tube, to get water out, is called a well. Okay, so let's explore this well idea a little bit more. Let's say that I start pumping the water out of the well. Okay, my engine's a little rusty. So what type of feature would actually form at the bottom of this well when it comes in contact with the saturated zone? Okay, this feature that forms is called the cone of depression, and you form your own cone of depression if you're sucking up a chocolate milkshake out of your cup. So now I'm going to draw the modified water table surface after pumping for a little while, and you notice that the water has gone down considerably. So what is that concept called when water kind of drops into the aquifer? So that's called drawdown. Question number 10. Here you are, you're minding your own business, and under you is a buried alien spacecraft, right? No, this is water that's actually above or elevated above the main water table, so what would that be called? So if you have water above the main water table that's trapped by a localized lens of shale and actually held in a sandstone, which is what I've tried to draw, that is a perched water table. Would it be possible to drill a well into the perched water table to get the water out? Yes, you could do that if there is enough water to supply your whatever with. So question number 11, I'm getting really fancy now and pretty elaborate with some colors. And I'm going to put some dots on this to indicate this is a certain feature. So here we go. You're going to see this picture 2 or 3 times in a row. So what type of aquifer have I drawn in this picture? That is a confined aquifer. And where would you find the area of recharge? Okay, the area of recharge is in the high mountains. This is the only place where water can actually get into that yellow zone. So we're going to name the parts now, I believe, in question 11b. So I'm drawing my pretty colors again to impress you. Okay, this time I've added some water. So this yellow feature is loaded with water all the way to that blue line. And this dotted line is called the potentiometric surface. It's a potential energy level of the water. So let's say I dig a well and I put it right at this level. The first question is the water going to flow freely out of this well? And the answer is yes. And is this an artesian well? Yes. Is it flowing or non-flowing? Okay, this is a flowing artesian well. Now in this one, the water only goes to this point, so I have to pump the rest of it out. So is this a flowing or non-flowing artesian well? And it's a non-flowing artesian well, and it still is an artesian well because the water level could potentially raise in the aquifer above the level of the well and cause the well to go from non-flowing to flowing. And also it's sunk into a confined aquifer, so that's what makes it a artesian well. So this is the last time you'll see this picture, I believe. And now we're going to name the parts of this system. So these gray layers here, what are these gray layers called? That's on top of and below the yellow layer. Okay, these are your aquicludes or aquitards, and this yellow layer is called this is your aquifer. Is this a common type of aquifer or not so common? And it is very uncommon. There's only a few places where you can find this, in the U.S. at least. So now we're moving on to question number 12 out of 20. This is pictures A and B. And which picture between A and B shows a gaining stream? Which one is a gaining stream? Okay, that's picture A. What about a picture B? Is that a losing stream? Okay, yes it is. So now in question number 13, I'm just chosen to arbitrarily take you to the continent of Africa. And the dots that I've drawn here are the locations of landfills. So are landfills, could they potentially be considered a point source pollutant or a non-point source pollution? Point source and non-point source. Okay, these are point source because you can trace their pollution back to the specific places. What if I told you that this entire region of Africa is loaded with arsenic? The arsenic concentrations are extremely high in this area. So now what would you say? Point source or non-point source? Okay, this is non-point source because you don't really know where the arsenic is coming from. Question number 14 is a simple question. Can you name some common groundwater pollutants? And there's many answers in this category. You can have sewage, you can have motor oil, chemicals, refinery, byproducts, all sorts of stuff. Highway salt. Question number 15, I have a nice picture for your consideration. What is this part of the groundwater system called? That is the unconfined aquifer, and this one, the unsaturated zone. Here below we have the saturated zone, and the interface again is the water table. And what feature is shown here with this asterisk? That's the cone of depression. Is this even an aquifer at all? Yes, because it's a permeable sandstone. That means that water flows through this rock fairly easily. Question number 16. What is this thing that is erupting hot water? That is a geyser, and it's different from a hot spring because a hot spring may just bubble water. So now in question number 17, your job is to fill in the blanks. So we have H2O plus something produces H2CO3. So what compound goes in the blank? Okay, this is carbon dioxide, CO2. So water from rain mixes with carbon dioxide in the atmosphere to form H2CO3, which you call acid rain. So this acid rain will mix with something to make CaH2CO3, which is calcium bicarbonate. So what is this acid rain mixed with? Okay, this is limestone or calcite or calcium carbonate, CaCO3. So question number 18, this whole double equation deal is going to be written for you again. And I haven't found a way that Doceri could just put it up there all at once. I'm sure there's a way, but we just have to be patient, and this is good practice for you anyway to see it again. So now we have the two equations up, so here is your question. Which equation actually makes carbonic acid? Which one makes carbonic acid? Okay, this is acid rain, H2CO3. That's the same acid in your Coca-Cola can. So question number 18Z. I guess I'm pretty bored at this point. So equation number 1 is making carbonic acid, and equation number 2 is making something called calcium bicarbonate. Okay, I'm sure these equations are not balanced. So we're going to consider the second equation now. Is this equation actually showing the dissolution of limestone? Is this dissolving limestone? And the answer is yes, because limestone is eaten away by acid rain to form calcium bicarbonate. So when this reaction actually goes the opposite way, this is how cave formations are formed. So now let's take you inside of a cave. So here you are, Mr. or Mrs. Spelunker, and you're looking at things that are hanging off the ceiling, and they're not bats. What are those things called that hang down from the ceiling? Okay, these are stalactites. And the things that come up from the floor are called stalagmites. And what are they called when they join in the middle? These are columns. Okay, 19, this is F minus G to the X. So stalactites and stalagmites, among all sorts of other types of things, are in a group of cave formations which are called by an S word. Okay, these are speleothems. So speleothems are all the beautiful cave decorations you can find. So final question in Chapter 10 Study Guide. This is an area of land that's surrounded by big pits in the earth. Maybe they have water in them. These are sinkholes. So if you live in an area with a lot of sinkholes, like I do in Kentucky, because that's where I'm from, what is that K word where you have a lot of sinkholes? Okay, that is karst, and specifically karst topography. Okay, so that actually concludes our Chapter 10 review session.